Okay, so I think we're ready. So last but not least, we have our closing keynote by Jordan, who is going to talk about, I don't know, doing more with Puppet and hug ops and being happy, I suppose.
Hug ops. I'm going to take this off because I'm probably going to strangle myself by accident. Nope, I'm not. Nope. In we go. Okay, excellent. Oh, where to start? So I'm here to talk to you today. I'm going to try and summarize the day in a way from things I've observed. And I want my intention here is to try and get you excited about new things you could do with Puppet. We're going to talk about 3 things. But first, a little bit about myself. As you can see from this picture, I'm not a great fan of safety, I guess, because my foot being, 10 centimeters from a very, very fast spinning blade. But I like friends. I consider you all my friends. I'm a big fan of this thing we call hug ops, where it's sort of the antithesis of what you normally do when you react when a service is down. Normally you get upset and then you go on Facebook or Twitter and you complain. We want you to do the opposite, because a lot of you may have on-call experiences or outages that you experience yourself, and you don't feel happy when you're dealing with things that are on fire. And so the idea is that we have all experienced this kind of thing where computers are upsetting us, they've fallen over, we build them to stand up, and they don't stand up. And so we just sort of channeling a little bit of love on the internet. And before I start talking about projects and things that we can do with Puppet and some other tools, is that my overall philosophy on, especially with respect to open source projects, is that if a new user is approaching a problem with a tool and they are having a problem, it's because of a bug. It might be a bug in the software, it might be a bug in the documentation, but the reason a user is doing something that appears to be wrong is because they were led to believe that something would work and it does not. So at the very beginning of today, Andy mentioned that Puppet Lab's goal is to drive down the cost of technological change. And I think my approach to doing that is through improving tools around the operational lifecycle, where you build something, and that may be something you build yourself, or you've purchased a piece of software or a piece of hardware, and now you're deploying it in production. And that deployment is separate from the acquisition or the building of the thing that you've now deployed. And then once it's deployed, because as humans, we seem to be incapable of producing systems that work for a very long time, especially with computers, now you have to debug them when they fall over. And once you figure out what has gone wrong, then you go back in the very beginning of the cycle and you fix what has been broken, and you do the build step again, you deploy it. And of course, you have hopefully fixed the one problem that was broken, and then another thing breaks. So my goal for today is to show you some tools that you can use to improve the speed at which you can do this cycle. I want to help you improve the speed of which you can build something, the speed and ease at which you can deploy something, and the speed and ease at which you can debug something. So with respect to building, what I'll be talking about is packaging in this particular thing. Building is a very, very complex thing. It's development of the software. It's deciding where it's going to run, what the requirements are. But fundamentally, the operations folks are usually left with, how do we get it to production? And most of that is through some kind of packaging. And I'll be talking about a tool that helps you with that. The second one is deployment. Deploying is getting it, once you've shipped it to production with some kind of package, maybe that's just by copying files around or whatever you happen to do, you need to run it. And I think running things is difficult. And I'll talk about why it's too difficult and provide an example tool that will help with that. And then lastly, I think debugging is difficult because things break all the time. And you might be debugging something that's important and another thing falls over, and now what do you debug first? Right? Things are always falling over, and we need tools that help us understand what the problem is so that we can know to go fix the problem. That was the last step. Excellent. So in Puppet, you can deploy a package like this. This is cool because you don't have to know what operating system you're on. You just say, please have a package named Redis, give me the latest one. That to me is neat. But how did you get to this point? Like, who provided you the Redis package? How is it distributed to you? Who builds it? Who owns the production of the package which comes to you? In most cases, it's your operating system distributor. Some package maintainer, often a volunteer, produces this package, ships it to the operating system distributor, whether that's Red Hat or Debian or Arch Linux or Solaris or whatever you happen to run. And eventually you would yum install it, your apt-get install it. But there's other cases. For example, Puppet with Puppet Enterprise. They provide their own packages. They're not an operating system vendor, but they are providing their own packages through their own repositories that you can then install. And then there's a third class where you're sort of feeding yourself. You have some unmet need that vendors or operating system distributors are not solving, and so you solve it yourself. And so a tool I will talk about today is called FPM. FPM solves the bottom two of these. I think Red Hat knows how to package software for Red Hat. I think that in many cases, you might be a software vendor, you might be an open source project maintainer, and you want to provide packages that people can easily install, but you don't know how. Or you know how for one packaging system like Red Hat, but looking at how to do it in Debian, it's a completely foreign system for you. So FPM tries to solve all of that. The first thing I will mention is that FPM is an open source project. It's free. It's led by myself as a hobby, but it's really a community effort. We have about 100 different people who have contributed code to it. It's a very friendly community. I mentioned very early on that, make sure I'm not running over time, that if you are running into a problem, it's a bug. I don't care how you got to the point where you're experiencing a crash or behavior that looks weird to you, it's a bug. And that's when you need to come to the community, especially if you use this tool, this community, and say, I'm seeing this weird thing, I would like it to do this correct thing, and then we can get to a path where it does the correct thing. And the project itself is about 3 years old. So why would you even think about using FPM? I haven't really said what it does yet, but we're getting there. So why FPM? This is an RPM spec. This one came from the Fedora project. This is the MariaDB RPM spec for Fedora 20. It's over 600 lines. That's a lot of things to maintain. And so if you are thinking about producing packages for yourself, that script that just flew by was something that would produce a MariaDB package for Fedora. But like, how much free time do you have to write 600 lines and debug it and maintain it, write it in the first place, learn the language that is required to writing it? My proposal is that it should just be easier. You should say, take this directory, turn it into an RPM, and call it something. That's easy, right? This is one line. The thing I showed you before was 600 lines. And once we start simplifying the interface, we can start thinking about abstractions. Like Puppet provides this abstraction on what a package is. You say, give me the Redis or the Nginx or the Apache package, and it installs it. And it knows how to do that simply by the name. And so lots of these packaging systems have the same properties. They have names, they have a description, they have some dependencies, they have a version. And so FPM gives you this system for taking packages in one format and turning them into another. If you have a Ruby on Rails application that you need to deploy to production and you don't know anything about Ruby gems, FPM can make you a Debian package of exactly that, which is really powerful. And so I will taunt the demo deities, and we will try a quick demo. That's good enough. Can everyone read this? So the original example above, in a previous slide, I said, take the Redis package and give me the latest one. Well, a lot of times, your upstream distributor, your operating system, Red Hat or Debian or whatever you're using, will provide you a package, a certain version of a package that you want. But maybe you need a newer version, and you don't want to wait 2 years for that package to come out. So you build it yourself. And so what do? You download it. You unpack it, you make it. That takes some time. You're going to install it somewhere temporary so that you know exactly all the files that belong to it. We see that Redis is very small in the number of files it installs, and now we package it. So that was going from download to RPM, like 6 commands? And the first 5 you're familiar with most of the time. You know that you download it. You know you compile it. You know you run configure, or however you do. Most of these open source projects will tell you how to download and install them from the command lines if they don't provide packages. And so now we added one additional command, and we said, take the output directory, install it as usual local something, call it Redis, version 2.88, and we have an RPM. We didn't have to know the internals of the RPM building system or the environment. We didn't have to know the language that you use to describe how to build an RPM. You just express it on the command line very simply. And we make an RPM. Very nice. And so then you could start thinking about doing this. So now that you have a clean way to build packages, a very simple way to build packages. And by the way, let's go back really quick. Let's rerun this very quickly. You'll notice that the only thing that mentions RPM or is specific to RPM is this thing here. Now, if I were to ask FPM to build a Debian package, I just changed 3 letters from RPM to Deb. Or if I want to build a Solaris package, I change RPM to Solaris. If I want to build an OSX package, I change it from RPM to OSX package. Very similar command lines, and you're making different packages. There are some open source projects that actually use this to produce the packages they ship. Docker, if you're familiar with it, uses it to produce their Debian packages. Vagrant uses it to produce their Debian and RPM packages. So we get to here. So now we've got this desire to have a newer version of something installed in production, and we've built it very easily and hopefully a path that is understandable and you can make sense of. And so now we can install it. Well, what's the next step? We're going to have Puppet install it, and then hooray, we've got the latest version. And we can ask the system, did it really install the right version? And it installed the files that we told it to install. And because it's an RPM, you get all the wonderful properties of it being an RPM. You can uninstall it. You can think about upgrading it. You can think about having dependencies expressed upon it. Well, what's the next thing you're going to be doing? You want to run it, right? Just having a package on disk doesn't help you a lot. So let's try and start it, right? And that doesn't work because the package doesn't come with a description of how to run the system. So maybe, actually that's the end of the FPM demo. Let's go on to the next project, which is a follow-up to what we were just doing in this path of building, deploying, and debugging. So in my opinion, which is you have to take with a grain of salt because this is a project I helped create, is that you have success. You can make a package very easily. You don't have to read the Fedora packaging guidelines, which are over 100 pages long. You don't have to read the Debian policy manual, which is over 150 pages long. I don't have time for that. And if you do learn some of these things, these things that are instructions for how to tell you to type things into a computer, well, we already have a system for that called programming languages. And so we can just write those instructions down and have them always in the computer and have a nice interface that we can say, make me a package of this. So we want to get, the next step is to get to here, right? I tried from the command line saying, start the Redis service, and it failed because the system doesn't know how to run it. So we could try doing it through Puppet. And it fails because we don't have a description on the system of how to actually operate it. And you're sad. But it's okay, my friends. Like packages, running a piece of software is, if you look at it, it's a simple thing. You're saying, take this program with these arguments, run it as this user. There's basically three concepts there. There are other things. You could have configuration files or other environmental limitations, but fundamentally there is a small list of the abstracted ideas you could describe for how to run a service. But if you've looked at any scripts in Etsy init.d, how many lines are they? 100? 200? 300? 5 lines? I've never seen a 5-line init script. Well, you could, exactly, right? It changes by the OS, right? Older operating systems will tend to have a bunch of really large shell scripts that share almost nothing between them. They're all implementing the same thing: start, stop, status, restart. Some of them have reload. Some of them have graceful restarts. But basically, there's like start and stop, status. Most things we'll be happy with. But newer operating systems ship with newer ways to run things. There's upstart, there's systemd. There's older systems that haven't been the default, like runit, daemon tools, supervisor D, monit. We got a big list now, right? The same problem you have with packages. There's RPMs, there's debs, there's Ruby gems. Python has its own thing. Perl has its own thing. No one agrees. So I think you can turn the frown upside down, and it's still a frown, but we can still make the problem a little bit better. And the solution I have come up for this, and there's a community around this as well, is something I'm calling pleaserun. And my proposal is that running stuff should just be way easier. We shouldn't have to write 100-line shell scripts. We shouldn't have to know that we are on a certain version of Ubuntu, therefore we use upstart, but only this specific version of upstart. And that in Red Hat 7, when it comes out, we're going to be using systemd. And they're two completely different systems describing basically the same things. And so pleaserun is another open source software. And the idea is that, like Puppet in many ways, it will detect the system that you're running on and create whatever is necessary to run a program that you've just described. And so there are five platforms supported right now. Most of them are Unix-oriented. LaunchD is an OS X one. So it is likely you'll be able to generate something. But if you are running an operating system that is not supported or a platform that is not supported, this is open source. I welcome any kinds of contributions. And so what I mean by that is not specifically code. If you know that, for example, you run Arch Linux or Gentoo uses OpenRC. There's no OpenRC support right now, but you can ask for it. And that, to me, is OK. It's OK if you ask for things and you don't provide code. You'll never hear me say, send patches or leave me alone. Because a lot of people, they can't code, but they know there's a problem with the system, and they can write down the problem, and then maybe when someone has time and energy, they can implement that solution. That, to me, is how open source really works. So let's talk about pleaserun in Puppet with a demo. Where were we? So pleaserun exists as an external program, an external library, but because you can extend Puppet with custom types, I provide a custom type. So now we're saying, install the latest version of Redis, make sure that something named Redis is runnable, and then you use the service type that's already built into Puppet to activate it. Because describing how to run it and actually telling it to run are two separate actions. And then you use the wonderful Puppet dependencies to make sure they are in order. And so now it's created the instance of whatever it means on this particular operating system to create a service, and now Puppet can manage it. Now we can manage it by hand if we wish to, or we can manage it by Puppet. But the point is, what I find with most operating systems folks and sysadmins is that there's a divide. Many people know how to start and stop systems. The interfaces for starting and stopping and asking for status or asking them to reload is fairly simple. But how you get to the description of what it means to restart, what it means to stop. With System 5 in it, it's a giant shell script. With upstart, it's a config. With systemd, it's a different config that means the exact same thing using completely different terminology than upstart. It sucks. We can abstract that. We have code that can solve this kind of problem. And pleaserun is how you do it. So excellent. We've reduced our time spent building packages. We've reduced our time spent trying to understand a new software running platform. If you're on CentOS 6 right now, I think Red Hat is a good example, because Red Hat 5 and previous had a bunch of init scripts. There were a bunch of shell scripts. Sometimes they use things in common. Red Hat 6 comes out, and they shipped it with upstart. Red Hat 7 is coming out, now you get systemd. So if you're running 3 generations of systems, you have 3 completely or nearly incompatible ways of describing how to run a thing. But pleaserun allows you to use an abstraction that can talk to all 3. So we talked about building. And with specific attention to packaging things. We talked about running things in production with service managers like systemd or init scripts. And now the final step is debugging things. And how many of you have seen something like this? Latency's looking good, and then something happens, right? I don't even need to tell anyone what the numbers are for this particular data set. But humans are good at visualizing things. They'll notice that the shape has changed and where the shape has changed. How about a more realistic example where we have something happening and it's okay. I don't know if can you all read the numbers? I tried to make it very large. But the idea is you have some kind of time on the horizontal axis and some kind of numeric value, maybe it's seconds on the vertical axis, and at some point it looks like at 1426 it all went to hell. And wouldn't it be nice if you could overlay things that were going on in your system at the time? For example, Puppet ran, and then everything went to crap. And oh, by the way, MySQL got turned off by Puppet. That kind of thing is useful. In my mind, the way I always joke about your first real success or signal of success with Puppet is that instead of having a single machine go down when you do a deployment, you have your entire fleet of machines go down when you deploy with Puppet. That's how you know you're doing it right, but now maybe you need some more testing or whatever. But the point is, you can orchestrate your entire infrastructure, possibly with a mistake, and have things go offline. And that's an accident of what Puppet gives you, but it's also a demonstration of the power that it gets you, that you can orchestrate all these things. And so this is my typical thing where things usually break. A piece of hardware has died, a network link has gone away, somebody deployed Puppet with a typo that made the version go backwards, and now everything is dead. So to solve that, there's Logstash. And Logstash isn't by itself. There's an ecosystem of tools that when you combine them together, give you, for example, that nice graph with the overlaying of metric data and plotting on the same graph, seeing log-oriented data. Records of Puppet having done things that you wish it didn't do at 2 a.m. And so my proposal is that there's a lot of log data on all of your systems. They're in different formats. They all speak a different timestamp. And they're unstructured data. Sometimes they're structured. Sometimes, like with Puppet's log output, they're colored. That color can often mean things. And that you need an interface for asking questions of all of this log data with a backend that scales. So we had something scroll by earlier. It was an RPM spec. This kind of data, we're going to have another similar example, in that logs, for example, require privileged access a lot of the times. If you log in as a regular user and look at var log messages, well, you can't because you're not root or you're not in the right group. And it also it's only understandable by experts. If you're trying to read the logs on the back of the screen, that's a problem, right? There's 20 lines, 30 lines here? How many events happen per second on all of your applications, on all of your systems in your infrastructure? A lot more than 20, and certainly a lot more than 20 per second or something like that. And so you've already lost the game of attempting to look at this kind of data. And even if you can look at the data, maybe there's only one event per day, and that's attainable, you can watch that. It still requires an expert level of knowledge of what the format of that log is. Like behind here is Apache logs. And so I know the far left thing is the IP address. And somewhere in there is the response code. But if we were to give this to, for example, the sales team to say, well, all of the purchases that have been made are actually in the logs. So here's the logs, and now we can compute, our revenue. They're just going to look at you like you're crazy. And they may turn around and say, well, I have no idea what this is, but you're the computer person. Type some stuff in, give me a graph. And maybe you have a burst of energy. You're like, yes, I'm going to do that. I like writing Perl. I'm going to write a cool one-liner in Perl. And it's going to make a graph. And you do it. And you make the salespeople very happy. And everyone feels good until tomorrow, when the salespeople want a different graph. Or the salespeople have talked to marketing, and marketing wants a completely different graph. They want to know how their advertising campaign is going. So now you're on call again to write another piece of Perl. And a week goes by. Now you've got 15 of these scripts. And the salespeople want, instead of a blue line, they want a green line. Because green means blue. Green means good, and blue means who knows. And so now you go back to this script, and you have no idea what it does. It's a big, half of it is a regular expression. What does it even do? I have no idea. So this poor tooling. You start with grep, you add a little bit of awk, a little bit of sed. Maybe you jump to Perl or Ruby or Python, whatever your favorite language is. Maybe you go to R. But the next day you have no idea what you just wrote. So it's not really solved. And this is especially important because if you have set these expectations of non-technical people in your business that you are the graph generator, now they use your ears, they use your face as a keyboard. Now they're typing things through your head, and you translate that through your brain into keystrokes. And maybe you have fun with that for a while until something catches fire. And now that's the priority, but now everyone else is in your office saying, we need a graph, we need a graph, we need a graph. So wouldn't it be cool if you could just take all of that nasty data that you would normally write these one-liners for and give them something like this? And you say, this is an interactive interface you can play with. So instead of playing with me, I can go do my job, and you can go to town on this, get all the graphs you want, change all the colors you want, make it big, make it small, put it on a TV, on a dashboard, I don't care, but just do it and let me do my job. That would be neat. So that's what Kibana is for. So Kibana is another piece of the puzzle where Logstash allows you to get away from that practice of writing these kind of janky one-liners that's parsing and chopping up logs. And Kibana gives you the visualization and the exploration. Exploration is important. By exploration, I mean there's no complex query syntax. You're not typing things into a prompt to say, take this data set and give me a pie chart. You walk around your data. You say, I want a pie chart, and so you drag one in, and you tell it what data set you want it to come from. It's interactive. It's friendlier to non-technical users, and it's easier to use for technical users. And once you've built whatever explorative dashboard that you want, you can save it and share it with your coworkers. So if at the very worst case, your sales team refuses to learn how to use this system, you can build them a dashboard, share it with them, and then they can walk around it from there. But what do you do in the middle? How do you go from real-time log processing, which Logstash helps you do, and visualization in real time and exploration that Kibana does? You need something in the middle, some kind of storage system that lets you search things over time. Maybe that's a week, a month, a year, 3 years. And that's Elasticsearch. Elasticsearch is horizontally scalable. So if you have one server today and you run out of storage space or you run out of compute capacity, you can add another. And then they form a cluster of 2 nodes. And then you add 5, 10, 100. It scales with you. The other property is that it provides near real-time search, in that as soon as your log data is sent into Elasticsearch, you're able to search on it within probably a second on average. And the third thing is that Kibana is not doing anything magical behind the scenes. It is speaking the same API that you would to Elasticsearch over HTTP. And so my proposal is that you take all of your logs through your entire systems and collect it in one single place, and then you can start asking these questions and answering them very quickly. You could have something that says, your pager went off because latency is high. You look at the past hour of latency, and it spiked 5 minutes ago. What went on 5 minutes ago? We did a deploy? Did a hard drive fail? Those type of things. All of this data is in your logs. So Logstash, I forget who said it, but they call it a Unix pipe on steroids. And that, so far I've said you take your logs with Logstash, you store it in Elasticsearch, and you visualize it with Kibana, but that's not the end of what you can do with it. There's all kinds of things. First of all, there's a lot of ways to get data in. You can read from files, you can read over the network, you can read from communications channels like IRC, you can read from email. How many of you have cron jobs? Those get sent to an email address. If it's you filter it, right? You get like 3 of them a day. You're like, I don't, cron, just root, stop emailing me. right? Email is a target for logs. Logstash has an email input. So it can read that, so you don't have to, but when there's a problem, you can see that this cron job has been failing for 3 weeks straight. And then once you take all of these log sources, I should mention there are other kinds of inputs. There's metric-related inputs, because in my mind, a metric is a log. Metrics and logs both have timestamps. Metrics are simply just a name, a number, and what time that number was recorded. Very much a log. And so to that effect, there's NetFlow inputs, there's graphite inputs. Logstash understands the graphite protocol, it understands the Ganglia protocol. So if you're using a lot of these systems already for monitoring, you can ship all of this data and have it visualized on top of your regular logs, which is very powerful. But that's not the end of this. That's not the end of the game. Getting your logs from somewhere is one step, but they're all in weird formats, right? You have to be an expert to understand a lot of these things. And instead of writing, my offer is that you don't write these one-liner Perl scripts that are unmanageable. But Logstash comes with what it calls filters. And filters are just different tools in your tool belt for processing different kinds of logs. There's a filter for normalizing dates, so that you can take 2 log formats with different date formats, like Nagios, for example, which uses Unix epoch, and syslog, which uses some date format that doesn't have a time zone or a year. Why? So if you're looking at last year's logs, what year did it occur in? You have no idea. And that's bad. But there are a lot of tools that we can provide to help you normalize this data, to pull out structure. What else can I tell you? I think that's enough about filters. And then the last step is that you want to get your data somewhere. You want to store it somewhere. You want to make it searchable. You want to send it to your operations communications channel, so that if there's an exception log you want to send to the developers, you can do that. If you want to send an email or file a ticket when a certain event comes in, or be paged when a certain event comes in. So again, we have this continued success. We have Puppet managing our infrastructure, and we're using some other open source tools that happen to work really well with the kinds of things you're going to want to be doing. And so, we have FPM for helping you with the build process. It's not going to solve all of your problems, but I hope it solves at least the packaging problem for you. And we have, for deployment, I don't have all the solutions for deployment, but we do have a tool that helps you get things running in production. And I think that's a step that's important, but it's not a step that's worth wasting any time or knowledge on. Knowledge is a very powerful burden. Knowing how to build an RPM from scratch is a burden. Knowing how to build a Debian, or knowing how to build an RPM from scratch is a burden. And then maybe you change jobs, or you get a new CTO who makes a decree that we're running Debian instead of Red Hat. And now all of that knowledge you have is worthless with respect to the job you need to accomplish. You have to learn how to build Debian packages. And they use the same concept. They have names and versions and dependencies, but they use different terms. RPM calls it a requires. Debian calls it depends. They're the exact same thing. Why are they different? I have no idea. No one communicates with each other. And the same happens with the deployment technologies, right? Systemd, completely in conflict with the terminology and the background of Upstart. But they both do the same thing. Take MySQL, run it. And for debugging, I think we've dug ourselves a hole. If you are acting as a developer, you write log messages that you hope are meaningful to you. But that's not often who's reading them. You have operations people who are reading them, possibly without the context that you had at the time you wrote them. And so what happens, especially with me, is that I will write a piece of software with log messages I hope are useful, and then 3 weeks later, like our Perl scripts we cannot maintain, it's a message that's in English, and I have no idea what it means. Error, such and such failed. I have no idea what that means. There's a stack trace with an exception. I have no idea what it means. It's frustrating. So that is the end. I tried to be quick. If you have questions, I'm happy to answer. I should disclose, by the way, that I am an Elasticsearch employee. I started the Logstash project 4 years ago. So the bottom part, the last thing I was talking about, is the vendor part of this. It's an open source project. and it's the only version of the project. There's no enterprise or no, I guess, open core model. That's the only thing we produce. But FPM and pleaserun are sort of community driven by love projects. So if you have any questions, I'm happy to answer them. And if you're interested, I can show you a short demo of the Logstash stuff with Apache logs, because that might be interesting. Yep. OK, cool. Let's do that. So sorry, you had a question. Yes. Yes. So I said that there's a lot of systems all implementing the same idea of like a dependency. A package has a name, a package has a version. FPM supports specifying dependencies, and it tries to be smart. For example, if you say, give me an RPM of the Rails gem. The Rails Ruby gem has a list of files. It has a name and a version, and a list of Ruby specific dependencies. If the internet is working, I will try and do a live demo of me doing Rails. Where's Wi-Fi? It's gone. This is terrible. Computers, we just can't make them work. No, Puppet Camp. It's better. Okay, so we're gonna taunt the live demos. Okay, so so the things I would note here is that I'm asking to build a Debian package on my Mac of Rails, and if it doesn't take forever. If the internet is up, stop downloading things. Okay, so let's actually show that over here, where I actually have Debian tools to show you that it actually does dependencies automatically. And at the same time, I will multitask. No, last 30 days isn't good. Let's look at last 3 months. This is Kibana, by the way, the visualization interface. All right, so dependencies. And I also want to show where it can be smart, it will be smart. So it made a Debian package. It knew, for example, that Rails is pure Ruby. So under Debian, that calls that the all architecture. Red Hat will call that no arch, or no arc, however you want to pronounce it. And this server is, Wi-Fi is dead. We'll come back to FPM when the Wi-Fi comes back. So my elevator pitch for Kibana is that logs are crap. If you look at a list of text, you're never going to understand the shape of that data. This data set, you can immediately see that there are at least 2 really outlandish spikes. And if you look closer, you'll see this kind of like bouncing curve. So shapes are important. But we could, for example, this is just the total number of events graphed over time for the past 3 months. But for example, if I wanted, instead of hits or number of visits to my website or things downloaded, I wanted, for example, bandwidth. More shapes appear, right? Something was very active, it went away, and it came back. And you can do things like ask for summarizations, ask for different shapes of the same data set. So I want to say, show me the number, the top user agents. Not as a bar chart. That's terrible. So this is important because we're asking for the same data. We're asking for the top and user agents. And you could view it as a bar chart, a pie chart, a table. The shape of the data matters. All right, so there's the most common user agent hitting this particular site is chef. It is a good example. And so, wait 1 moment. So I asked this, the magnifying glass says, include this as as a filter in the search, and then the circle with a slash through it says exclude it. But so we included it. And when we did that, we're zooming in. This is the exploration. I'm not typing things in, I'm clicking and poking. Humans are great at poking. Especially, I feel like operators, developers in the hacker mindset, like you look at something and you like poke at it and it breaks, you're like, well, that was weird. I bet I could do it better. These things that fall apart. And so we can, for example, have a theory that, this chef client is the only reason this shape exists. Let's get rid of that filter, for example. So I can have a theory that says this particular client is the cause of this weird shape. And so if I exclude that data set from the result, the shape should go away, right? The big spikes should be gone. So if we exclude it, the shape completely changes. So now we can zoom in. We can say, okay, well, we know it's this weird chef client. Come on, browser, don't die now. All right. What else can we do? We can ask, so we get the top terms, for example, for user agent, but what is it downloading? So let's look at the top things. And this is just one example of drilling into a data set. And I think it's not as cool of an example as I could give because it's only one source. My proposal was having a latency graph and then understanding that you told Puppet to do a bad thing and therefore a bad thing happened. Those are two different sources of data. One is the health and metrics from your application, and the other one is Puppet logs or system logs. Request. So let's look at the top 10, and we will find that it's only requesting one file. So this, from this, knowing what Chef is, I would posit that it's someone's Chef cookbook is downloading Logstash and trying to install it over and over, possibly a poorly written cookbook. So we can zoom in. Let's keep zooming in. We get closer and closer to a time interval that makes sense. Let's look at a full 30-minute period. And it's fairly rhythmic. And I bet that, and I won't go into it, but I bet that we can say, like, show me the top 10 IPs, and there's probably like 10 or 15. And it's all one business that's doing this. And so someone's chef is waking up every few minutes. I'm sure you have Puppet waking up every few minutes trying to manage your system. But saying, it's time to make sure Logstash is installed. And it's written in a way that it downloads it anyway, even if it doesn't need to do work. Right? We all make weird configuration mistakes like this, and this is just something that persists. So again, without knowing anything about my data, I was simply exploring around. I saw a shape. I looked at the weird shape. I tried to identify the top or the most common cause of something. You can do neat stuff when you have a way to explore your data. So let's go back to FPM. Broken pipe. Come on, internet. Yes? So we had FPM build, take the Rails Ruby gem, and make a Debian package out of it. And there's some interesting properties you should note. It knew what version it is. It knew what license it was, because the Ruby gem describes it. Again, we have all of these completely different packaging formats with slightly different goals, all using the same basic ideas. It knew who made it. It also knew the dependencies, because the Ruby gem describes the dependencies it has on other Ruby gems. I think I answered 2 questions at once, but yes, good. We can go deeper. I don't know. One cool thing is that FPM, for example, has RPM and deb support for inputs, so not just outputs. So if you have an RPM that is broken, but you can't find the source RPM, or you don't wish to find it because then you have to learn how to rebuild it, you can take the existing RPM. Let's just rename this Debian package. So we're taking a source of a deb, and we're making a new deb. Dun, dun. Let's change the name to Fancy Pants. So I created a package based on my previous package, and everything should be the same except for the name is changed. So you can see not just the file name has changed, Debian's interpretation of the package name has changed, but all of the dependencies are still the same.
How does it know the name of the dependency based on the distribution?
So that's a hard problem to solve because they try and be consistent, but they're actually not. So for RPM, let's just gem. I will make it RPM, and I'll show you the difference. So in the dependencies above, it's ruigem-name, right? And that makes sense a lot in Debian's world. But with RPM, they tend to use something else. Oh, that's not what I wanted to type at all. So now, again, this is the exact same command line with 3 characters changed. Very simple. If you were to try and do this in RPM spec, you'd have a bad time. It looks like I already have a package, so we'll just look at that one. RPM, just QI? No. Wet, copy and paste failure. No, requires. So in this case, it's generated them in what I believe is the Red Hat way of expressing library dependencies. I don't know. It is this way, and it's been this way for a number of years, and no one who uses FPM has complained. So that to me is fine. I mean, if you, there is one divide, I think, that FPM makes. So FPM tries to unite you with your code. And for example, if you have developers that are in-house producing software and they have no idea what packages look like in production, and they're like, look, a tarball, let's deploy that. Let's just unpack it. Like, well, no, you can introduce them to RPM, to FPM. FPM has a tar input. FPM has a zip input. Like, if you have a pile of things, a pile of files on disk, let's name it, give it a version and some dependencies, and boom, we have a native format.
You also supporting directories, native directories.
Yeah. Directory.
For Red Hat systems, do you take the SE Linux tag of the directory?
The what? The SE something?
The SE Linux tag for that directory.
SE Linux tab. I'm not sure I understand the question.
So each directory has a label.
Yes.
That allows a specific program to read or write from that directory.
Oh, the access controls.
Yeah, exactly.
So let's look at. I'll show you in a second. So I want to list the files. I never remember the name of the command line. There we go. So I said take a directory, which is, in this case, you can give it files or a directory name. If you give it a directory name, it's recursive, but I didn't want to make a giant package. So this package is named myhomedir is awesome, and it contains my ZSHRC file in the path I told it to be in. But if, for example, you want to build, and we'll come back to yours, don't let me forget that. Maybe I think my config is the best, so I want to copy this into -f. So now I said take my .zshrc and move it to this other place. Very simple. The idea with what I just showed was that you don't have to create the directory structure beforehand. You can just put files wherever you want. And you asked something about Etsy. Who owns the files? Ask your question.
If I want to use FPM but not pleaserun,
Yeah, so they're separate projects.
I know, but can you integrate pleaserun into RPM?
That is the plan. So the files are owned by root by default. You can change that. Because I have been saying so far that many packaging systems, I will point to you shortly, many packaging systems implement the same ideas, the same kind of primitives, a version, a name, a dependency, conflicts with a certain thing. There are places where there are deviations. Right, you'll see this in Puppet too. You'll see you can start a service, but if you are targeting a specific service, you can say this provider. And once you specify a provider, you can specify other options that are specific to that provider. So FPM has a lot of flags. And for example, there's a bunch of gem-specific ones. There's a bunch of RPM-specific ones. So if you know that you need a special feature that only RPM has, there's probably a flag for it. There's like 100-something flags. It's enormous. So in that way, we have packaging systems that agree on the fundamental shape of the world, but they go all of their separate ways. Did that answer your question?
Can you
A special depend. Yes. It would be, and this is the second time I've had that specific question. We'll have it depend on hooray and see what happens. I need that. -f. So the -f flag just allows me to say, well, if the file already exists, go ahead and create it. So I said -d, which is short for -- depends. It should add an additional dependency. And this is in cases where you want the automatic dependencies that might come from Gem or Python or Ruby or Perl. Depends. Seriously. So we still have the Ruby Gem dependencies and the additional one that's hooray. So yes, your hand was up first. This is my favorite question, and we're working on it. I want you to be able to say, here. I want you to be able to take this command line and add -R for recursive. And that will get you Rails and every single one of these dependencies and any of its dependencies. So you'll get like 100 Ruby Gem RPMs. That's what I want. Right? That would make me happy. There's the documentation this project has is small, but that's because I want people to keep telling me the documentation sucks so I can make the tool easier to use. But in this case, there is a wiki entry on saying, well, I have this big chain of dependencies. I don't want to create a gem, create an RPM, look at the automatic dependencies, create all of those. We have a script in the wiki that does it. You had it. Then you.
What about binary dependencies? You know, auto-req and RPM handles also binary.
I turn that off by default because it's stupid. But there's a flag. So I tend to be vocal about what I think is silly and irrelevant in the world of software. But that doesn't mean my opinions on how I do things should affect your ability to use a tool that is good. That's how we ended up with so many of these packaging systems in the first place. Right? We'll have an agreement on the core, but pointless disagreements about the names of a thing or like small differences in the ways that we should execute. And now you have RPM and whatever Arch is using and FreeBSD's thing and package source and Gentoo's thing. It's just no one agrees. So I was ranting and something specific to a package format. I forget what you were asking.
RPM, no, because if you build a package which depends on the library,
Yes, RPM calls that auto requires or auto provides. So those are off by default because I think they are stupid. But other people like them, so there you are. That will re-enable it. You had your hand up, and then you.
So RPM supports delta RPMs. Is that
Does anyone use those?
everyone?
Everyone uses those. So delta RPMs, I think, are a cool technology in that if you have really, really large RPMs, it's faster to install, I guess.
Yeah, it installs just the diff between the two RPMs.
So FPM doesn't support that today, but if you wanted it, I could think of, for example, I'm not sure how we would abstract that, but I think we could. There's another example of something RPM doesn't support that I think would be useful to have as like FPM could hack around it. For example, I believe Oracle database is like 10 or 12 gigabytes. The maximum size of an RPM, because of the storage format, is 8 gigs. So you already can't have an RPM for it. And I think that sucks. And we could, for example, have FPM understand that limitation and break it up into chunks that has the dependencies all lined up correctly. So you could yum install Oracle, and it just catted everything together, and you wouldn't have to know about it. But you could still use Puppet to package install it. Like, that is neat. Instead of having what you would have instead is like a bunch of execs in Puppet if you're using it for that. And it's just doesn't make me. There are limitations in systems we can work around.
Planning to support different repositories, like the creation of the repository for this package?
So distribution is a separate problem. There are tools out there that solve it. There's one that's called PRM that tries to solve for repositories what FPM solves for packages. So it supports Debian repositories or Yum repositories. There is, if you can, and I have no financial ties to this whatsoever, but there is a site called Bintray that I've been tinkering with. And why I think it's cool is because the interface for you is you upload an RPM, and then it provides you the Yum repository or the Debian repository. Let me see if I can show you, for example. I had a Redis demo up. Da, 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 da. Let's make it smaller so I can actually get there. I'm not familiar with the interface, but there is set me up. Downloading packages. So as a user, you want to download packages with Yum. So it gives you the Yum repository crap that you have to paste into your server or use a Puppet module to install. And then you can Yum install things that you are hosting yourself. So I think the repository problem isn't well solved, but these folks are attending to it. You had a question.
Can it also generate Debian changes files?
So what's the point? And when I ask you that and I say it very sarcastically, is I have no use for these things. Like, if you have use for them and you need them, then let's do it. Let's figure out how to make it work.
Unfortunately, we have to use them because our company runs a very old Debian repository. Yes, still.
So you use a tool that requires a changes file? Can it be empty? Can it be full of lies? Like every time you...
Verifies every single MD5 sum. It's absolutely correct.
So my recommendation for the next step there would be that let's try and get that solved, because I know that there is at least one repository management tool for Debian that requires this file no one cares about. I mean, we have config management like Git and SVN. If you want to know what changed, the Git log, SVN log. But let's go ahead and take that data and embed it in the package, and let's make it required. So now we have the 2 copies of everything. So the whole idea of Delta RPMs is saving space. Now we're just wasting space. Like, come on. So yes. So my suggestion would be email the mailing list, the Logstash, the FPM mailing list, or file a ticket saying, because I am in this weird constraint, I would like this tool to help me automatically manage my changes file. And I think one of the other things that I will be very opinionated against the weird and strange world of packaging, but you don't have full control over everything in your infrastructure. Like, if you could get out from under the wing of requiring these changes files, which you may or may not use, like, maybe you would. But maybe you haven't made the decision to say, this is useless information, we don't need it. There's a policy you can't affect, but we can work around it, right? Someone over here had their hand up. Sorry, for which operating system? I'll repeat the question. macOS. I have never heard of it, but there is what I can tell you is because we can abstract things. So there are two packages. They're not really packages. There's 2 crazy fun hacks that FPM supports. One, you can take a directory or an RPM and output a Puppet module. Don't do it, because then you'll have a Puppet module with 1 million files. But it's funny because the abstraction is there. The point of that is like kind of an illustration by humor. The fact that you can turn an RPM, unpack it, and you get a Puppet module. There's another one that we received, a patch we received previously that apparently is serious. And these folks use it at work. I don't know what constrains them to use it, but it's basically a shell archive. And it's a script that you run, and you can tell it to install it or uninstall it. And so we have this idea already of being able to, if you can create an installer, you can create an uninstaller. So that might work for you. If you have constraints that your packages or however you need to do require a different shape, we can totally support it. And I think the incentive there is that you only have to, in FPM, if you need a new target, like if we don't support RPM but you want RPM support, in your case you want macOS, that you only need to make the output side of FPM work, and you get all the inputs for free. You get RPM converting to something else. You get Ruby gems converting to your format.
Okay, I'm going to interrupt for a minute. I've already let Jordan go 15 minutes over. He's been going for an hour, which is why he needs a drink. How many of you think we should cut off the questions and go drink beer? Wait. How many of you think I should just let you continue barraging him with questions for more time? Okay.
I'm here till tomorrow.
All right. And he will be here for drinks, correct?
Yes.
Yes, so he'll be here for drinks. So you have an opportunity to hammer on him for more questions one-on-one.
Those are all very good questions, by the way. Thank you.
Yeah, excellent questions, which is why I let him go over. Okay,
Alan.
so next up, and the only thing left, is drinks. They're upstairs. Go straight through the place where you've been eating lunch and having coffee. And you'll see the restaurant bar right at the back of that room, and that's where we're going to meet up.
Hi.
So keep your badges on, because that's what will get you the drinks.
Oh, you want the slides? I will give that to you.